Okay, so now that we have the background that we need to move forward, let's do so. So the thing I want to define is p-colorability of a knot. So usually p is going to be a prime number, but it doesn't always have to be. But so anyway, here's our definition. A knot is colorable mod p. Sometimes we just say p-colorable. P-colorable. If we can assign a number to each strand, by a number I really mean an integer, to each strand of our diagram for our knot, such that, and there are two properties. The first one is that you're not just using the same number at for every single strand. You're using at least two numbers. And the second is the I'd say more important thing that we need to specify, and that is at each crossing. So let's say we have our over strand is labeled by X, and then our under strands are labeled by Y on this side and labeled by the integer Z on this side. So if we have this, then we need the equation 2x is congruent to y plus z mod p is satisfied. So in other words, if I add my two understrands, that should be equal to 2 times the overstrand, modulo this prime number p. It's extremely difficult to have this be satisfied without the mod p restriction. Or having this this thing mod p makes this condition easier to satisfy is what I mean by that. So yeah, anyway, so this p is basically going to be our number for our knot. Okay, that's not exactly true, but you'll see what I mean a little bit later. So let's do an example. So the trefoil is 3-colorable. So I'm going to assign numbers to the strands. I'll assign to this first strand the number 0. This second strand will get the number 1, and this third strand will get the number 2. Could have done 1, 2, 3 if you want. Doesn't really matter. Okay. So we have 3 crossings here, which means that we have 3 equations that we need to satisfy. Okay, so let's zoom in on each crossing and figure out what our equation should be. So keep in mind that I'm giving you the 3 coloring right here. You won't necessarily always be like given a coloring of something and being told to verify it, but more on that later. So let's go to crossing 1. So what's our overstrand look like? So our overstrand, oh boy, our overstrand looks like this. So that is labeled with a 0. So I'll go ahead and label that 0. And then my understrands are going to be a 1, 1 coming out the bottom right, and then a 2 coming out the top left. So that's the 2. Okay. So now our crossing relation should tell us that 2 times the overstrand is congruent to 2 plus 1, the sum of our 2 understrands. And this is, so I'm claiming that this is colorable mod 3. So these have to be congruent mod 3. And in fact, on the left I get a 0, and on the right I get a 3. And 0 and 3 differ by a multiple of 3, therefore they are congruent mod 3. So it works for that one. Let's do it for the second crossing. Second crossing, I have this picture So my over strand is going to be a 1. And then strand coming out the top right, that's a 0. And then the other one's going to be a 2. So I should get 2 times the overstrand is congruent to the sum of the understrands. And in this case, this just trivially holds because I have 2 on the left and 2 on the right. So that's pretty easy. Let me back out again. Sorry. Okay. And then third crossing. What's the third crossing look like? Third crossing, my overstrand is going to be a 2, and my understrands are going to be a 1 and a 0. I guess I should draw it like this. That's a 2, and the other ones are a 1 and a 0. And then I should get that 2 times the overstrand is equal to the sum of the understrands, mod 3. So I get 4 on the left and 1 on the right, and in fact those are equal to each other mod 3, or congruent to each other. Okay, so this is a 3 coloring of the trefoil. So the theorem that goes along with this is that if, alright, so this is a 3 coloring for one specific picture of the trefoil. I could have given you this picture right here, and done a similar thing here. I could have also given you this picture of the trefoil. Here I have 4 strands, and so you would maybe have to do something slightly different. And the theorem that goes along with this is that if one picture for a knot, if one diagram for a knot is 3 colorable, then every diagram for that same knot would also be 3 colorable, or p-colorable in general. So yeah.